Welcome to today's session of the GuestXR webinar series. Today's session will be on protest dynamics in extended reality. So my name is Jessica Norbert. I am a project manager for the GuestXR project at Eurecat. We are the leading research and technology center in Catalonia, Spain. So thank you for attending this webinar, and thank you for your interest. We are very excited to have you here. This webinar is part of our broader commitment and broader mission to open up to our research to new audiences. So of course, we would like to thank first Frontier, the co-organizers of this series of webinar. Thank you for your support and for bringing this conversation to life, of course. Maybe a little bit of context on the GuestXR project. We already started the webinar last week, but for those who might have missed it, I would give a little context, before diving into the topic. So GuestXR is a project, research project funded by the European Commission. The point of the project is to leverage and to explore how AI agent can act as a social catalyst in immersive environments. So what is the idea? The idea is to help participants navigate conflict, cooperation, and of course also foster empathy when they have these gatherings, these encounters in the extended reality. So the project used a mix of extended reality, neuroscience, and machine learning. And at its core, there is this machine learning called the Guest, which is designed to achieve the goals, the participants' goals within this meeting in the extended reality. No? So this is the last year of the project, and the project is implemented by a multidisciplinary team. We see here our partners, the consortium. We are composed of researchers, developers, creatives, and we are working at the intersection of technology and social science. So, of course, the idea of this project is not just to build virtual tools, but to build this more connected and empathic metaverse, no? Yeah. So, as I said, today's webinar is focused on protest dynamics. We are going to explore together how reinforcement learning can modify or modify behavior. So here we look at an AI agent trained with reinforcement learning and how it interacts with the users within protest scenarios. So this scenario that we will see, one of the scenarios that we will see is one famous, the women's strikes in Poland. Of course, we will see how it more deeply afterwards. But the study was selected through the open call of the GuestXR project, which was also an initiative for us to bring in new voices and new experiment into the research community. So without further ado, I'm happy to introduce Ana Luisa, a professor at the Arctic University of Norway. She co-leads the Perceptra Lab, which specializes in physiological measurements in extended reality. And together with Andrea Robinson, a master student, they are doing this research, which we will explore right now within this webinar. So yes, thank you all. Just maybe, my bad, I forgot to remember this session is recorded, and we will share the presentation and the record through the email. So, Ana Luisa, over to you. Thank you.
Thank you all for joining this session. And I am going to be presenting this research, but I want to stress that the main bulk of the work has been done by master student Andrea Robinson. She is actually a master student at NTNU, where I also collaborate. So unfortunately, she couldn't be with us today, but it is really essentially her work that I am going to try to communicate to you. So I hope I can do justice to what Andrea has done. But a little bit of the reasons of why we engaged with this topic, how we came into this, and also why we applied to be part of the GuestXR through the open call. On the one hand, I work in the Center for Peace Studies at UIT, the Arctic University of Norway, and I supervised a couple of years ago a master's thesis in peace and conflict transformation, where Alexandra Krysewinski was looking at this particular protest, the women's strikes, and I, from my own background, have been interested in this type of movement, also because I come from Panama, a country which has seen lots of political upheavals in its time. So the topic itself was interesting, and then I also had the opportunity to know more about the women's strikes from my master student. So in addition to that, I have had a long-term interest in the XR or in virtual reality technologies, and I have developed different kinds of simulations and so on. So it occurred to me that it could be a way, this open call could be a way to explore how one could use these types of technologies for research within the context of peace and conflict transformation studies. So this is groundbreaking in the sense that I haven't seen this type of research being done in this format. And by that very reason, it means that it's at a very early stages, as you will see during the presentation. So we wanted to know if an AI agent based on reinforcement learning could succeed in shaping the human behavior within this VR protest scenario. And the idea was then to recreate these women's strikes and test them. So I first started by exploring what imagery was available about the events. And my student, of course, had given me a lot of the historical context and the kind of everyday experiences of participants in the protest before I started looking at it. But at the first instance, I just wanted to have a reasonable representation, a scenario that could work just for initial tests. So I used this image from a Reuters report about the protests and tried then to recreate the environment in this way. In addition to this women's strikes, I also was thinking about experimenting with two other scenarios, of which I did one test that was about the Be Water protests in Hong Kong. So I'll just show you that one, and then I'll show you the scenario that we ended up using, which was the women's strikes. So this is the Be Water protests recreation. So in this particular test, the idea would be to see how the participants would react, also with their through seeing that through their physiological responses to this mass of police approaching them. That was one idea that we didn't test further, and then the one that we did test was this women strikes. But this version that I'm going to show you was the one that I recreated in like the full scale version in Unity. And as I will later explain, we had to do quite a lot of modifications to this in order for it to work in the platform that we used for testing. So I'll show you the full version, so to speak, first. Yes, so this is the full scale version. And then Andrea came in with an idea of trying to use the AI agent to see how the behavior of the participants experiencing the protest could be modified. So she created this experiment where the AI agent would have three different possible um, behaviors, so to say. So in the three different experimental groups, in the first one, the AI agent would randomly select its actions. In the second, there would be a probability decision threshold for random versus selected actions according to the AI agent's optimal policy. And in the third group, the actions would be based on the AI agent's optimal policy. And this is the main floor plan of the participants, where they would be placed in relation to where the AI agent would be placed and how the interaction would start. So if you recall from the VR video, their starting point is next to a lamp post. That's the entry point for the participants. But the main bulk of the protest action is happening further down, close to the Palace of Culture and Science. And this is where the AI agent is placed, its starting point. And the idea would be to see how the behaviors of the agents would make people come nearer to the protest center as defined by Andrea. So one of the things that we had to do with the scenario in order for this to work was to transfer it to the Keen platform. And this is a virtual bodyworks. And here I have to say that Bernhard Spanlang from Keen was really instrumental in making this whole experiment work, because he was the one who transferred all of the scenario that I had created, removed the avatars that were not making it playable through a streaming network, and it replaced some of those avatars and introduced the AI agent itself, which then Andrea used to create her own model. So this was really a full collaboration with Keen, and I'm very pleased that very happy with all of the process. But in any case, this is the idea, and then the representation that you see here of the different, the number of people and so on, that changed dramatically, and we couldn't use as many avatars or as many animations of crowds as would have been optimal to recreate the event as it really happened. So then in Andrea's research, the idea would be to use the position of the sensors of the position feedback, and also the feedback coming from a polar heart rate wearable clock that would then be sending these signals, and then using a Q-learning policy that would help the decision-making process of the AI agent. So this is the dimension of the laboratory that was used for the testing. So it's located in NTNU. This is the Sensity lab led by Professor Andrew Perkis, with whom I collaborate. And Andrea conducted all of her tests in his lab. And that space is about 4 meters by 3.7 meters. So if you think about it, it's a really reduced space in comparison to what the real events were like. And I will come back to that point later. This is the AI agent that was created by Bernhard and Spanlang from Keen and was used then by Andrea in her tests. Is a man dressed in regular clothing. Uh, so Virtual Bodyworks also provided all the Python scripts for retrieving the position of the participants within the XR environment, and the Python scripts for retrieving the ECG signal from the polar heart rate monitor, and also the functionality for managing the AI agent. So this had to do with the movements of the AI avatar and recording a function that record the movements, stored it in the database, and then had the agent perform these pre-recorded movements. So these are the actions that were defined as the AI agent's action space. The first action was that the agent's avatar would walk to the participants. The second was that the AI agent walks to a point near the midpoint between the center of the protest and the participants' starting position. The third action was that the AI agent looks at the participant. That is, that specifically it directs its gaze towards the participant head and maintains eye contact for 5 seconds before looking away into the distance. And the fourth action is that the AI agent makes a motion resembling a beckoning gesture intended to encourage others to follow it. So the participants' distance to the center of the protest is discretized then into a value ranging from 0 to 5, where 0 indicates the closest possible proximity to the protest center. And then there's a reward function that is defined in these different levels that then provides feedback to the agent and determines which action it is going to take. So in the experiment itself, there were 61 participants. So the first 20 participants were assigned to group 1, the next to group 2, and the final to group 3. And this is the graph of the results of the distance, the mean distance of the participants to the center of the protest. So as you can see, there is a complete overlap. So there is nothing that is statistically significant in these differences. And there was, this of course has to do with the sample size and so on and so forth. But there are some other things that we consider could be also a reason for this overlap. Um, so this is also a representation of the the distribution of the heart rate variability state and the distance across the explored space. So in the horizontal axis is the HRV state, and in the vertical axis is the distance state. And what it means is that the lower the heart rate variability and like at a middle distance from the center of the protest, that was the main type of activity that was registered by the users. So Then the second part of the experiment was that after completion of the experience of the simulation, the participants were asked a series of questions. And these questions were designed to understand what the perception of the participants was of the AI agent. So they were asked to what extent they had been aware that they were interacting with an AI agent, and 46 of the 61 respondents indicated that they were unaware of this. 13 reported being somewhat aware during the experience, and only two of them reported that they were fully aware that that took place. The respondents were closely to equally divided among the three groups of participants. However, it is worth noting that the two participants that were aware of the existence of this AI agent, they all belong to group three, which is the group where the AI agent was using its optimal policy. Uh, so despite the differences, all participants noted the presence of a distinct character moving in the XR scenario. So they did notice that this particular avatar was different from all the others. So we assume that it was visible for everyone that this was a special kind of participant in it. But they didn't recognize that it was an artificial type of participant. So this is the distribution of how the participants interpreted the AI agent's goals across the experimental groups. So they, in their responses, gave different reasons for how they thought that agent was, why they thought that agent was acting as it was acting. And then Andrea classified that doing thematic analysis into these five different categories of responses. So some of them thought that that avatar was there to encourage them to protest. Others just thought that it was there to move in the XR scenario. Others thought that it was there to frighten or discomfort the participants. Others thought that it was there to discourage participation in the protest or encourage movement away from the protest. So, and finally, there were other responses that were just classified as generally as other. But it's interesting that the majority did understand that that avatar was there to encourage them to participate in the protest. However, these three that were there thinking that the avatar had as reason to discourage them or to move away, there will be some implications about that as well that I will present later. So some conclusions then about what we can gather from this experiment. Uh, So the experimental setup itself may have limited the AI agent's effectiveness due to the constrained physical space, which prevented participants from moving freely and significantly approaching the protest. And many participants mentioned that limitation during the experiment, saying that they wanted to approach the protest, but could not because of space limitations. And moreover, observations during the XR scenario supported this, as several participants explored the boundaries by extending their arms and indicating a desire for more room or interaction. And in her thesis, Andrea also shows, this gesture that many participants were just trying to reach above the limited, and they just kept finding the boundaries of the simulation. Uh, So the other thing that Andrea gathers from this is that the participants' desire to explore the boundary of the movement space could be the result from insufficient stimulation in the XR scenario itself. And many participants frequently stood facing away from the AI agent and asked questions such as, is anything else going to happen? Can I just walk around, or will there be more activity? And in retrospect, it might have been beneficial to incorporate more dynamic elements or simple non-critical tasks to maintain engagement, and or kind of go away from this aimless movement. And there are, as said, there were some limitations in due to this becoming part of a platform that was going to be streamed to the Oculus device, where we couldn't have this very heavy processing of all of these the avatars that would be more a more realistic representation of what was happening in the actual protest. So in a way, it was it became a more minimalistic, so to see, to the representation of the protest. So that may have been quite detrimental. But at the same time, I do see Andreas pointed that if there had been maybe some tasks for the participants or more some storytelling components in the simulation that could have helped, but then it'd be another layer of complexity and of consideration in relation to it being trying to be a historically accurate kind of representation of it, and not a gamified version of the event. So this is also Andrea's own notes that the technical requirement to stream the XR scenario also involves some limitations in the realism. So the only significant finding from the regression analysis that Andrea conducted was that those participants who perceived the AI agent as attempting to induce fear maintained a minimum distance that was on average almost a meter greater than those who did not clearly interpret this purpose. So what she found is that there were three participants that were convinced that, first of all, this was an AI agent, and secondly, that agent had as goal to scare them. And those effectively, the results were that they were standing one meter away, further away than all the others. No? So this was kind of an interesting combination. So from my point of view of more of this concept, proof of concept design and development through this opportunity with the open call, was that we succeeded in implementing the concept because we did have this AI agent interacting and learning from the interaction in a historical reconstruction with all these participants. And we were able then to connect the physiological and movement data and feed that successfully into the model. But then the issues that we encountered was that one of them was that the simulation effectiveness could also depend on the reconstruction of the actual spatial dimensions of the event. And I've just been thinking after reading Andreas' thesis and what has happened so far. Yeah, this is something I really hadn't considered, I guess, when I was designing the scenario. The fact that I was trying to shrink this huge open space into this tiny lab setting, and then also in terms of the crowd itself, like all the shrinking of the simulation in terms of number of people and of actual dimension. You know, there are other design considerations that I hadn't consciously kind of considered. So that's has me thinking about also how that can affect all of these place illusion and plausibility illusions and so on. And then this we know a lot about, of course, the storytelling component, the sounds, the other events occurring, and so on, that were underdeveloped for this particular experiment. There could be a lot more of background or of introduction of the participants, and of course, I'm trying to recreate this feeling or this emotion of being, or this response of being there in this place at this time to people who have no connection to these events, but some of them may have connections to other types of protests or not. This was not something that that we looked at. So that would be something that would be interesting as well. But then, if trying to use this simulation to teach people about, this topic of protests more generally, like I would consider for the courses that we have at the Center for Peace Studies and so on, what kind of storytelling would be required for this type of simulation to be meaningful? And then in which other ways could we use this AI agent to express something about this type of event and so on. So there is like a technical setup that I think we have been successful in constructing and creating together, but then it needs a whole lot of work in trying to expand the project to make it into something that can provide some useful results further down the road. So that's what I would like to say about this project. And if you have any questions, I'll be happy to answer in the capacity that I can. And again, apologies for Andrea not being here today.
Okay, thank you, Anna. Thank you, Anna, for that presentation. It sounds like very interesting study that you did there. Unfortunately, some technical, I understand, limitations affect the result of the study. Nonetheless, you did make some how would I would say, not maybe groundbreaking would be the term, but some very interesting findings there. Let me see in the chat if we have any question. Okay, so for now we do not have question yet. uh, I will give maybe 1 minute to give time to write in the chat if you have any question. One question that I may have in the meantime, if I may, Anna, and sorry if it's not maybe of your domain. So, when you were saying, for example, that some of the participants, sorry, a certain number of the participants were not aware that there were this AI agent. That can make us think about the ethics, no, behind this, because this can be something dangerous as well as beneficial. So, what is your take on this? Do you have any comments? Yeah.
Yes, absolutely. And this is something that we discussed quite a lot before, when the project was accepted, to proceed. We were having these meetings and discussing quite a lot about what type of experiment, what would be the ethical implications, and so on. And in the end, we concluded that for now the AI Act, or in at that time that was under development, it would allow us to proceed with this type of experiment because it is in the context of research, and then the
Mhm.
participants would be well informed about what was happening afterwards. So this was part of the question, and but it continues, of course, to be a big question for the whole development of these virtual worlds, because the majority didn't they did notice this was a different type of agent, but they
Mhm.
assumed it was another human. So that is really something to also to think of as an important finding, that it's that might happen to the majority of people, and then we have a lot of implications coming out of that. So it was possible for us to proceed in this way because it was within the context of research. But
Mhm.
I then would even say from these tiny findings that this is something to really, really be thinking about when we are designing these experiences, because people will not necessarily think this is an artificial being.
Yeah. Thank you. And I think yeah, okay. So we have a question from Narcisse. The only movement possibility for participants was walking in the real space. So there, it's like a two-part question. Couldn't they approach the AI avatar through teleportation or virtual walking?
Yeah, that is one of the solutions for this shrinking space problem. Like, how do you translate the actual big dimensions of the real space into this tiny constrained simulation space? We could have done that, but I think that that would have added yet another layer to the project. So in this case, it was just kept simple with the exam set axis. But we definitely could have explored this possibility. But I do wonder though whether that would make it move more into this gamified sense of it. Because ideally, I think for this type of reconstruction, which was trying to be kind of close to the real events, they would have to be able to walk those
Mhm.
distances. And so it's just a problem of translation that puzzles me now.
Thank you. I hope that answered your question, Arsis. Feel free to ask again if not. And that was all for the questions. Um, yeah. So yeah, that answered the question. So from my side, I believe it was pretty clear. Thank you, Anna, for presenting your findings. Although Andrea could not be here, it's also interesting to see her work. I believe we can stop here for today's session. Let me just remind our next webinar. So for next session on our seminar series on the 19th of June, we have the seminar on uninvited guests. Can AI applied neuroscience improve virtual reality meetings? And of course, there is the last series of this webinar series. Sorry, on the 26th of June, when AI joins the table, intelligent agents, and in the metaverse. So, yes, thank you again for attending today's session. You can find all the information and register to these upcoming sessions on our website, guestxr.eu. Thank you again also, Anna, for joining, and thank you all for your interest. Yeah. So we
Thank you.
can stop here, and we will see you in our next session. Thank you all. Bye
Thank
bye.
you. Bye.